Good morning, student. Today our topic is formation of alcohol from alkene. From alkene, we have two methods for preparation of alcohol. First, we discuss about acidic hydrolysis of alkene. A very simple reaction and most important reaction for formation of alcohol. Here we can say that when alkene undergoes hydrolysis undergoes hydrolysis in the presence of protonic acid. In the presence of protonic acid means those type of acid which have capacity to donate proton. These are called protonic acid. In the presence of acid like H2SO4 or so many, it gives alcohol. It gives alcohol H, C and OH. This is any type of alkene, and this is water molecule. H plus is present the proton, means protonic acid, and the formation of alcohol takes place. If see this type of reaction in any other example, suppose we have a propene CH3 CH double bond and CH2 plus HOH water molecule. It undergoes hydrolysis and the formation of CH3 CH CH2 EH and OH. Simple reaction. Here we can understand the mechanism of this reaction. Suppose in this reaction the bond is break so this carbon became positive charge and this carbon became negative charge, and hydrogen atom form H plus and this form OH minus ion, and H plus comes to this carbon and forms C single bond H, and OH comes to this carbon and form C single bond OH. This is alcohol and this is similar here, but the mechanism of this reaction is very typical, so we understand by in detail mechanism. Mechanism can be explained in three following steps. In the first step, this is the reaction is hydrolysis. Hydrolysis reaction in the presence of protonic acid. So this is most important point of the proton. In first step, water molecule H2O accept proton H2O plus H plus, means water molecule accept proton and form hydronium ion H3O plus hydronium ion. And in this step can be seen the formation of carbocation. We have C double bond C, means a type of alkene, and alkene react with H3O plus hydronium ion, and it donate proton, and here this double bond is break through this type. This carbon became positive charge and this carbon became negative charge, and H3O plus ion by the reverse reaction donate one proton to this alkene. This is type of alkene, and the double bond is break through like the arrow, and this carbon became positive charge and this carbon became negative charge, and it gives the C single bond C here, H, and this carbon became positive charge and H2O molecule is formed. And here we seen that one hydrogen is added, means H plus is added to C negative and form a single bond C single bond H. And this compound contain positive charge. This compound, so this ion contain positive charge, so it is called carbocation. Carbocation. So the first step is also called the formation of carbocation by action of hydronium ion. This is the first step. And in second step, carbocation bonded with H2O molecule and form a most reactive intermediate, and the reaction can be seen as we take these two last product C single bond H single bond C carbon positive plus H2O. We know that oxygen have lone pair. Oxygen atom have lone pair, two lone pair, and here carbon contains positive charge. This carbon contains positive charge, means carbon have electron like center. So oxygen donate electron to carbon. Oxygen donate electron to carbon and form a very reactive intermediate, which can be write as HCC. Here oxygen donate electron to carbon, and so oxygen became positive charge and became a bond with carbon, and the compound is written as HCC. Here single bond OH and H, and the positive charge moves toward oxygen because oxygen donate electron to carbon atom, means carbocation, and this is a intermediate of the reaction. And in last step, third step, another molecule of H2O comes. First we take the last product CH H and plus, this is the last product, and the other molecule of H2O which have electron rich center, means lone pair electron, it donate electron, and here this oxygen have electron like center, but electronegativity of oxygen is most than other element of the bond, means oxygen have more electronegative than hydrogen, and oxygen also more electronegative than carbon. So oxygen take the electron of this bond, and means this bond is break like this. So this hydrogen became positive charge and oxygen became negative charge, means positive and negative, means oxygen become neutralized, and this bond is break. And it form the CHCCO and H, and here H plus is removed, and this H plus is combined with H2O and form H3O plus, So we seen here the reaction is started with the attack of H3O plus ion, and reaction is stopped, means product is formed by removal of H3O plus ion. So this is the mechanism of acetic hydrolysis. Again we explain simple, here H2O and H plus. it form H3O plus ion, and H3O plus ion attach to alkene and donate one hydrogen to carbon and form the carbocation. It forms the carbocation and H2O molecule is removed. And in second step, these two compound or these two ions and compound combine together, and here oxygen have lone pair, so oxygen donate electron to carbocation and form an intermediate, and in last step intermediate undergo hydrolysis and remove the H plus ion and form the final product. So this is the first method for formation of alcohol from alkene. And next, the second method, and the second method is formation of alcohol from alkene is by hydroboration. This is simple reaction. Here we can see that when alkene is react with diborane, that B2H6, diborane B2H6, diborane in the presence of sodium hydroxide as base. When alkene react with diborane in the presence of base, it gives alcohol in the final step. The reaction can be write as CH2 double bond CH2 plus B2H6 plus B2H6. Alkene react with diborane, it forms trialkyl boron, and trialkyl boron undergoes hydrolysis by peroxide H2O2, 6H2O2. It gives alcohol. But this reaction can be simply written as following types. Here 6 molecule B2H6. B2H6 is also write as BH3 whole twice or simply BH3. Simplest form of the diborane is BH3. So I write this reaction in the form of BH3 and also explain the mechanism of this reaction. Here we take only three molecule, 3 CH2 double bond CH2 and plus BH3. You not confused what BH3 and B2H6, both are compound are similar. This is the simplest form, like AlCl3 and Al2Cl6, both are aluminum chloride, and this is the simplest form, and this is the complex form which contains bridge bond. So these two means BH3 and B2H6, both are similar compound that present the boron hydride diborane. So here 3 molecule of alkene CH2 double bond CH2 plus BH3 react together and form the here BH3. I can break the BH3 in the form of HBH2, H plus and BH2 minus, and the double bond is break like this. Then one carbon became negative charge and other carbon became positive charge. Anyway, like this can be like that. This carbon became negative and this carbon became positive. Both are similar. So when the BH3 molecule is break, it forms H plus ion and BH2 minus ion. So H plus is add with CH2 negative and BH2 negative is add with CH2, and a product which comes, this is the CH3, CH2 and BH2. These three molecules we can take in three steps. Here only one molecule, and next we write the second step. So it is clear, one carbon became negative charge and other carbon became positive charge. BH3 break down like this, H plus and BH2 minus. And when again we react this compound CH2 double bond CH2, one carbon became positive and other became negative, and BH2 is break down in the form of H plus, means this compound is break like CH3, CH2, BH, H, H plus and B minus, BH minus. So the product it comes like CH3, CH2, BH, and the other molecule of hydrogen is add with this carbon, means negative carbon, and form a chain CH2 and CH3. And in third step, the third molecule of CH2 double bond CH2, here we write firstly 3 CH2, then 1, 2 and 3 CH2. This hydrogen also come to CH2 and form the CH3, CH2B, CH3, sorry, CH2 and CH3 and CH2, CH3. Means all the three hydrogen of BH3 moves toward the CH2 and it became CH3, and the other part of carbon is bonded with boron, or simply it can be write as B, H, H and H, BH3, and the molecule of CH2 double bond CH2, CH2 double bond CH2 and CH2 double bond CH2. What happened? Boron remove their hydrogen, and this hydrogen goes toward here, this hydrogen goes toward here, and this hydrogen goes toward here, and this carbon became a bond with boron. This hydrogen, when this hydrogen moves to CH2, boron makes a bond with CH2, and here similar, it means all double bond breaks and it forms CH3 and CH3. So this is the CH3 CH2B and CH3 CH2B. This compound is called triethylborane. Triethylborane. It can be also written as ORR, CH3 CH2 whole thrice into B. CH3 CH2 whole thrice into B. And in last step, CH3 CH2 B. The three molecule of H2O2 here, because here 6 and here 3, then not 6, only 3. 3 molecule of H2O2 comes, and H2O2 is the hydrogen peroxide HOH. When one hydrogen peroxide is break, it forms OH and OH, means 2 OH. It forms 2 OH, 2 hydroxide, means one peroxide gives 2 hydroxide. So 3 peroxide gives 3 hydrogen peroxide gives 6 OH. Then 3 OH comes with or bonded with CH3 CH2 and 3 with boron, and the product is 3 CH3 CH2 OH and BOH whole thrice. It can also write as H3BO3. And this is the method of formation of alcohol from diborane. Thank you.